Welcome to YouTube channel scientific_math. In this lecture, we discuss the third point of the learning objectives, and that is the concavity and point of inflection. In previous lecture, we discussed the concavity of the function when the function is concave up and concave down. How we can determine the concavity of the function? I will provide the link in video description. You can watch. Okay. So in this video lecture, we discuss the point of inflection and we will solve one example related to the point of inflection, and we will find the interval where the function is concave up and the function is concave down. So let's move toward the point of inflection. So first we discuss the definition of inflection point, and then we solve example related to the inflection point. Okay, so for if the function f is continuous at a point a and the function changes its concavity at a, then this point is an inflection point of the function. Okay, so what is inflection point? This mean if the function changes concavity of the function at this point, mean for example, and this is the point that is inflection point a f of a. We can see before this point the function is concave up, and after this point the function is concave down. So this is the inflection point on which function changes its concavity. And so we what is the behavior of the second derivative of the function is in this interval. In this interval, the derivative of the function in this from in this interval from minus infinity to a and from a to positive infinity. Okay, so we discuss the behavior of the double derivative of the function on this interval from minus infinity to a and a to positive infinity. So since the double derivative of the function and the second derivative of the function is greater than 0 for x less than a, this means uh, the derivative of the function over here is greater than 0 for all values of x that is less than a. Okay, so this means the function f is concave up over the interval minus infinity to a. So in this interval the function is concave up. Yes, we know that when the double derivative of the function is positive or greater than 0, then the function is concave up. And next, since since the second derivative of the function is less than 0 for x greater than a, this means this is the region where x greater than a, and in this region the double derivative of the function is less than 0. Okay, so the function is concave down over the interval a to infinity, concave down. And we know that when the double second derivative of the function is negative, then the function is concave down. So this means the point, this one is an inflection point. Okay, so now we see with the help of animated graph the concavity of the function and the point of inflection. Okay, so this is the graph of the function, and this is the point of inflection on which we will see the function will change its concavity. Okay, here we can see the second derivative of the function is positive. This is the second derivative of the function is positive in this interval from here to here. This one is positive. This means the function is concave. So this is positive. This is positive, positive, and from this one we can see the second derivative of the function is a negative. This means the function is concave down. Okay, so this one is negative. This one is negative. Okay, so this is the point of inflection on which the function changes its concavity, and we can see that from here to here, in this interval the function is concave up, and in this interval after the point of inflection the function is concave down. Okay, now we solve example related to the point of inflection. So this is we have an example for the function, that is the given function find all intervals where f is concave up and concave down. It's mean first we find the point of inflection and then we find the interval in which the function is concave up and concave down. Okay, so to determine concavity, first we find the second derivative of the function, and the derivative of second derivative of this function is, and this one, this is the second derivative of the function, and if the function changes its concavity, it occur either when the derivative of the function is equal to 0 or undefined. This means and the at the point of inflection, the second derivative of the function will be 0 or undefined. Okay, undefined. Okay, so since the second derivative and this one is defined for all real numbers, its mean we only find the only find where the second derivative of the function is 0. We find only the point or the value of x where the second derivative of the function is 0. So we put this one is equal to 0. Okay, after putting the second derivative of the function is equal to 0, we get the values of x. The value of x is equal to 0 0.5, and this is the point on which and the at which the derivative of the function, the double derivative of the function is 0. So uh, we have the point of inflection, and this is the point of inflection on which the function changing its concavity. Now we divide the interval from minus infinity to positive infinity into small intervals. Okay, so here we have interval from minus infinity to point of inflection 0 0.5, where the derivative of the function is equal to 0 or undefined, and then from 0 0.5 to positive infinity. Okay, so we take some test points to determine the sign of the double derivative. Okay, so we take point 0 from this interval. Okay, and here we can see the sign of the double derivative is positive. We put this point into this function, the double derivative, and we if we put okay, if we put x is equal to 0 over here, we can see the value of the function at x is equal to 0, that is positive 3. It's mean the double derivative of the function is positive in this interval. This means the function is concave up. Okay, next we again we take some test point from this interval, like I have like 1, and we put again this 1 into this function, and if we put the x is equal to 1 in double derivative, we can see the double derivative is okay negative. This is negative, so and the sign of the double derivative is second derivative is negative. Its mean the function is concave down. Okay, so we can see that from minus infinity to uh, minus infinity to 0 0.5, the function is in double derivative, the second derivative of the function is positive, and that is concave up, and from 0 0.5 to positive infinity, the second derivative or the double derivative of the function is negative, and here the function is concave down. Okay, so next we see this with the help of graph, animated graph, and here we can see the double derivative. Here the this one is the double derivative, second derivative of the function, and this is positive. And here we can see at this point the second derivative of the function will be 0. That is the point of inflection. This one is 0. And after the point of inflection, the second derivative of the function is negative. Okay, this one is negative. Okay, this mean the function is concave down. So here the function is concave up, and here the function is concave down, and in this interval the second derivative of the function is negative, and in this interval the second derivative of the function is positive. So thank you so much for watching my video. Please subscribe my channel scientific underscore math.